So we talked about evaluating functions in an equation. Let's talk now about graphing functions visually. And I'm going to pick up kind of where we left off, which is with equations. So let's take this function right here expressed in an equation, right? F of x equals 2x plus 1. And at this point, I hope everyone is comfortable kind of with what this means, which is that I can plug a number in for x, and I'll get an output for f of x. So for instance, I could plug in 1 for x, 1 times 2 plus 1 is 3, and on and on and on. Well, let me keep track of this with a table. So I have x over here and f of x over here. Again, we're dealing with the same concept, which is this input-output machine, but I want to express the data with a table. So if I plug in 1, what do I get as an output? I just said 2 times 1 plus 1 is 3. If I plug in 2, what do I get? Well, 2 times 2 plus 1 is, what is it? 5. Took me a second there. If I plug in 3, 2 times 3 is 6 plus 1, 7, and on and on and on. And I could plug in 100 if I wanted to. 100 times 2 is 200 plus 1. That's 201. So this goes on forever and ever and ever. But here's where we make the jump from equations and algebra to graphing and a little bit of geometry. Instead of calling this f of x, right, function of x, what if I chose to call this y, just as a shorthand, right? So instead of having to write out f of x every time, I just write y. So this table is an xy table. I'll say f of x slash y, right? It's an xy table. Well, if you're familiar with the xy coordinate plane, which I hope you are, but if you're not, welcome to the xy coordinate plane. Here it is, right? The xy coordinate plane is a very simple, but I think very profound concept. It's 2 lines, left to right, up to down. I'm doing the head motions to go along with it, right? Left to right, up to down. And what we do in this coordinate plane, in this picture here, is we take points and we plot them. I don't know if you're familiar with the board game Battleship. It's pretty old at this point, but the idea is you're trying to figure out where certain ships are, and you'll say like A5, right? It's the same idea. There are 2 coordinates that meet at a very particular point. So for instance, let's take this point right here. When I plug in x into this equation, the output, the f of x, is 3. So when I plug in 1 to this equation for x, the output is 3. So that means it's 1 on the x and 1, 2, 3 on the y, right there. Boom. What if I plug in 2? Well, when I plug in 2 for this x, 1, 2, the output is 1, 2, 1, 2, 3, 4, 5, right? So it's 2, 5. And 3, 7, and on and on and on. Now, I don't want to get too far ahead of where we are right now, but you can see that I can connect these points to make a graph. And it wasn't the best drawn series of points, but you see what I'm saying. I can connect these points and they make a graph. So I just want to pause here and flag the simplicity, but also kind of the cool nature of this. We can represent the same idea in an equation like this, in a table, or in a graph.